histogram. So it looks like there's some skew, but again, we don't really like the histogram. It's not a great way for understanding if we meet normality or not. Here, it's very clear that there is skew, so we do not meet normality, okay? What do we do when we don't meet normality? That's a very good question. Usually, you can transform and see what happens. Sometimes you need to do another analysis. Okay, so this is not really an ending point. This is the residual plot, right? So what you want to look for here is anything that's greater than 2 standardized residual. The outlier that I was telling you about that we saw in the scatter plot is right here. So it looks like that we do have an outlier, okay? We want to see if our residuals are evenly scattered across our mean line. So I would double click here, and I want to create a mean reference line. So I'm going to click on this value or this little diagram over here. It says add reference line to y-axis. I'm going to click on this, and I want the positions to be at 0. Click apply, and then I'm going to close out. Okay, perfect. So now I can actually do a comparative of the dots. So if the dots or the points are randomly scattered above and below the mean line, then it looks like we have equal variance. In this case, it doesn't look like we meet equal variance at all, okay? Because the lines, the points don't really randomly scatter above and below the residual plot. So we don't meet equal variance and we don't meet normality. So I would not run a simple linear regression for this model, okay? Based on my my assumptions. Yes?
Sorry, how did you get the line in the middle?
So I double click, and then I'll get this output, and then I go to the top.
Oh, it just, okay.
Yeah.
Got it.
Okay. Okay. Randomness is just random assignment versus random selection. We know about this already, so I'm going to go with this. Okay. So this, this is another way to look at our plots. So this looks really nice. The normality seems to be met over here on my slide. And at the bottom, this is my residual plot. This I definitely do not meet equal variance here, okay? Because I have a curvy here. So things you don't want to look for, or things that you do not want on your residual plot, are those two things. Anything that looks like a curve and anything that looks like it expands as you go, okay? If something that looks like a curve, that means it's not linear. That means you need a higher order term. So you need a square term, you need an interaction term, or something like that. If you have something that looks like at the bottom, that means you don't meet constant variance. So your model is just not a good fit for this particular data, okay? And this is from the lecture slides, which sort of talks about, what the NPP plot can give you an indication about. So what kind of skew? Is there a right skew or a left skew? Is there long tails? Are there short tails? Okay. Transformations are an art. You don't really know which transformation you need to use until you sort of use all of them, okay? And sometimes you do need to use all of them, sometimes you don't. So, if I was going to transform, if I transform from RASP to RAP squared to RAP, to the power of 4, I'd get the graph on here. So this looks a little bit better, but I had to really change my term here. So something like this is a good indication that you need to transform or that you need a higher order term. Okay, so again, transformation is really an art. So the most important part is really to how do you interpret things. Okay, so we had a coefficients table, and we have our ANOVA table, but we need to have that in words. We need to write out what that means in words.